functionality within that. For any class, if we wanted to make use of it, we need to create an instance or an object. What does that mean is, we need to allocate some memory to that to make use of the functionality within the class. So, if we wanted to make use of the functionality of the class, we need to create an instance, that is, an object is created, which means an memory has been allotted for that. So, there is a class A, and its instance has been created, so something like object A. And there is another class called B, so for which we have instantiated, and object B has been created. So there are two objects, object A and object B, on separate memory locations. But object A hasn't been used for a long time. We are not using object A, and it's sitting idly in the memory without making use of it. So Java has a feature, if any object, if the objects are not in use for a long time and they are sitting idly, then they will be removed. That memory will be used for some other objects which are in need of. So those objects will be garbage collected. So this process is called garbage collection. So since that memory can be perfectly used or I can say powerfully used for some useful purpose, so the performance will be very good with Java. So this is how Java does automatic memory management. As a Java, another feature is it's both a compiler and interpreter. What does that mean? When we write any Java program, so Java program, when a source code is being written, that source code has to be saved with .java extension. So any source code or any Java program we write, we need to save it with .java extension. So when we write .java file, that .java file has to be compiled to see are there any errors. So compiler, the job of the compiler is to convert the source code into a bytecode. It is nothing but, it is called as a .class or .class file. So .java file, a source file, will be converted to .class file. What is the class file? .class file? A .class file is nothing but a bytecode. So compiler's job is to convert a source code into .class file. So what happens once we get a class file? Java has an interpreter which takes this .class file, which has all this bytecode information, and the .class file will be sent to JVM. So what is JVM? JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. So what is the job of interpreter here is to convert or to send .class file to JVM. So what does JVM do here? JVM, Java Virtual Machine, it performs the following steps. First, initially, it verifies the class file, which is nothing but the bytecode. It verifies the bytecode using, it has a feature, or it has something called bytecode verifier. The JVM has bytecode verifiers. So with the help of it, it verifies the bytecode. Are there any errors? So initially I said a compiler, if there are any errors, it will display the errors before converting into .class file. Those are called compilation errors, like syntax errors, or like if you are missing a semicolon, or if you are missing any syntactical problem, those will be displayed as compilation errors before it is converted as .class file. It's the job of compiler. Whereas once a .class file is created, the job of interpreter is, or the job once it has been sent to JVM, the JVM, it verifies the bytecode, and those bytecodes, if there are any errors at that point, those are called runtime errors, right? Like example, there might be something like an object which hasn't been initialized properly or instantiated properly. So there is some null value which is being passed to that. So some examples of runtime errors will be like null pointer exception. So that means those are like application related errors, and those are not syntactical errors, but there is something problem with your coding itself and some logic within your code. So a bytecode verification will be done, and if there are any errors, those will be displayed. If everything is fine, then that class file, that .class file will be loaded into memory using class loader. So class loader job is to load that .class file into memory. So once that is being loaded, now the execution takes place and we'll see the output displayed onto the screen. So this is the job of a JVM. So Java, it does both the things. It's a compiler as well as interpreter. So both of it will be taken care by the Java, and it does a perfect thing. So if usually JVM will be available on every operating system, on most of the operating systems I can say, but if JVM is not available, then there will be .jvm chip available. We can download that, and you can install it along with your operating systems, and you can make use of it. But nowadays with most of the operating systems, it is inbuilt and it does all these steps. So the next feature of Java we have seen is it supports OOP concepts, which are object-oriented programming. So what are the OOP concepts? So in any interview, if you go and if they ask you what are OOP concepts, you can simply remember it's a very easy thing to remember. It's a pie. You can say it's a piece of cake. So how is it a pie? A stands for absence, P stands for polymorphism, I stands for inheritance, E stands for data encapsulation or encapsulation. So let's see in detail what is abstraction means, polymorphism means, inheritance means, and encapsulation means. Abstraction. It is also called data abstraction, or you can say abstraction. So what is abstraction? The process of abstraction in Java is used to hide certain details and only show the essential features of the object. So what does that mean? I can give a best example for this. Suppose you have a car. So you make use of a car, you drive the car. But do you really care of what a car will have? It will have an engine, it will have a steering, it will have tires, it will have so many others, windows, seats, etc. Do you really care how an engine is created, how a steering is created, or how they have been manufactured? Do we really care? No, we don't. We just care about, we know that it's a car, and we just make use of the car object. So, how does this reflect to abstraction, or how does this is related? So, if we take, and another thing is, so for any car, it might be of any different model, an Acura or a Lexus or Honda or whatever, it has all these features, the same features, an engine, a steering, tires, etc. So, however, an Acura dealer or Acura model, he wants to develop his car, he will manufacture his car with his own engine type, his own steering type, and different features. Similarly, Honda and similarly others. So, how do we really relate this car to our abstraction? So let's say I have created a class called class car. So there is a class car, region and different features. So in Java,